So we're going to move on to another section of factoring. So we already did GCF, the greatest common factor. Now we're going to move on to day 3. This is going to be factoring a trinomial where a equals 1. And I'll explain what that means in a second. So what we're going to do is figure out how to factor a trinomial with a leading coefficient of 1. So remember we talked about coefficient. Coefficient is just the number that's out in front. So we're going to be specifically looking at this form. ax squared plus bx plus c. So this is going to be the form that we use, ax squared plus bx plus c. And a, b, and c are all going to be numbers. So specifically when we do factoring like this, we're going to be looking at this where the a value is 1. And this is also called a trinomial because tri means 3. There's 3 terms, 1, 2, 3. And it goes in descending order. It's in standard form, x squared, x, and then just your number. This is the ones we're going to be looking at where the number out front here will be 1. We're going to learn how to factor that today. But first, let's do some problems that we already know how to do, and then we're going to do the reverse of it. So what we're going to be doing is multiplying these 2 binomials together because there's 2 terms in each one of these. And you should already know how to do this. So I'm going to draw my arcs to multiply these together. So this is something we already know how to do. We're going to multiply these together. We get x and x, which is x squared. Then we do the next one. X and 5 is 5x. And then we have 3 and x. That's a plus 3x. And then 3 times 5. That's 15. So then we look at these and we say, oh yeah, we can put these 2 together in the middle. So we end up getting x squared plus 5 and 3 is 8x plus 15. So here we have our trinomial. There's 1, 2, 3 terms, and the number out front here is 1. So we're going to learn how do we start with this equation and try to go backwards to the original with 2 sets of parentheses. So really you have to think about, well, where does this 8x come from and where does this 15 come from by looking at these starting problems here. So where does that even come from? Let's try another one where we multiply them together. So we do x times x squared, x times 1, so that's going to be 1x. Now we got to do the negative 4 times x is negative 4x, and then negative 4 times 1, negative 4. Combine like terms, again, the middle ones go together. 1 minus 4. So we have x squared, 1 minus 4 is negative 3x minus 4. And again, now we have some minus signs in here. That's okay, though. No difference. We still have a trinomial, and out front is 1. So we're going to figure out how to go from this back to this. This going that direction would be how we do factoring. So how are we going to go from, how are we going to use these numbers here to go back to negative 4 and 1 and fill in the blanks here? You should notice maybe kind of how they're similar. These 2 problems are similar compared to the 2 answers that we got. So I'm going to show you how to go backwards. This method is actually called the shortcut method because there's a very long way of doing these problems, and we will learn that for more complicated problems, but not right now. These ones are very simple, so I call this method is going to be called the shortcut method. So far we've done GCF, greatest common factor. This one will be called the shortcut method. So I'm going to go ahead and go through here, and then we'll do the steps down below of how to factor it. So when a is equal to 1, so remember I'm talking about this form, ax squared plus bx plus c. When a is 1, what you do is you set up 2 sets of parentheses. It's kind of like back here. I'm setting up these parentheses over here. See that? So with the variable in the first position of each set. So whatever variable we have, most likely it's going to be x. We're going to put an x in each first position like we did here, like we have here. See how there's x in both these first positions? So what I mean by first position is like this is the first position here, and this is the first position in that parentheses. Same thing here. So that's going to be pretty standard, putting x in there. And then you're going to find two numbers that when you multiply them together, it gives you C. Oh, what's C mean? That's this last one right here. So we're going to look at this last number, figure out what two numbers multiply to give you C. But those two numbers also have to add together to give you B. So it's like a little kind of like a math game. You have to figure out what two numbers can I multiply to get C, but they have to add to get B. Once you find that combination, and you know the two numbers, you use the two values to fill in the second position of each set of parentheses. So this might seem a little weird at first and not know exactly what's going on, but as we do it, these 2 or 3 sentences here will make a little bit more sense. So we're going to try one. For example 2, factor the polynomial x squared plus 5x plus 6. Okay, so first we're just going to identify what A, B, and C are. So A is the number out front here, we have B here, and C here. So we're going to say A is 1, B is 5, and C is 6. Right? I'm just matching them up with the one up here. So the only time you can do this shortcut method is when A is 1. So right now we know A is 1, so we can continue doing this method. All right, so we're going to set up two sets of parentheses. I'm going to write this stuff down here, and then we'll fill in the step 2. Set up two sets of parentheses, because we know that's what we're going to get. And then we have to put the variable in the first position of each set. So our variable here is x. We're just going to put x and an x. All right. Step 2 says define the two numbers that multiply to get, what are we trying to get? Multiply to get C. Our C value was 6. We're trying to get two numbers that also add to get 5. All right, so usually I'll go off to the side and say our C value is to multiply to get 6, and our B value we're trying to add to get 5. And then I'll just write it out on the side. So what options do we have to multiply to get 6? You have 1 times 6 and 2 times 3. Those are the only options you have. So what combination will work to add to get 5? It's got to be 2 times 3. That gives you 6 when you multiply. However, if you were to add them, 2 plus 3, that gives you 5. So now that we have our two numbers, we're just going to write our two binomials. They're both positive, so you put pluses here. And one is a 2, and one is a 3. And it does not matter whether you put the 3 here or the 2 here. You can flip those two around. It doesn't matter. So real quick, I'm going to show you that this gives you the right answer very, very quickly. If you were to multiply these back together, you would get x times x is x squared. X and 3 is plus 3x. Then these two would give you 2x. 2 times 3 is 6. And finally, combine those two. X squared plus 5x plus 6. You don't have to write this part out. I'm just proving to you that this is the same thing that we started with, if you can see it. Let's erase all this here. See, it's the same thing that we started with. And so this is the factored form. So really, we just got to figure out what combination works to get us, the two numbers that we're trying to find. We're always looking at C for multiplication and B to add. You just need to memorize that. So it does get a little tricky, especially when you add in negative signs. You see there's negative signs on these here? We have to use them as negative numbers. So for instance, we're going to label A, B, and C real quick, and we're going to take out what C is. So we're trying to multiply to get C. I want to get negative 32. That's an ugly one. So you kind of have to practice doing this. We're going to multiply to get negative 32, but then we're adding to get B. So I'm going to put that down here. B is negative 4. So always start with trying to figure out what multiplies to negative 32. What kind of options do you have? You could use what? 2 and 16? But one of them has to be negative, right? Because 2 times 16 is positive. So you need a negative 32. So you can make one of these negative. It could be negative 2 or 16. But adding them together, even with a negative sign there, is not going to give you 4, or negative 4 rather. So what other combinations can you use? That's what you have to figure out. How about 4? 4 and 8. Make one of these negative. So what if we made the 8 negative? So what's 4 times negative 8? That's negative 32. What if we did 4 plus negative 8? Ah, here we are, negative 4. If you have the negative on the 4 instead, realize that would give you a positive 4 here if you add them together, if you switch these signs around. So we need to make sure we get a negative 4. So these are our special numbers, and I'll just highlight them. So we need to use 4 and negative 8. So we do what we did before, set up 2 parentheses. First position is always x and x. That allows you to get to your x squared right here. And there are 2 numbers, would be 4, positive, and the other one is negative 8. That's it. All right, going on to part B. We're looking to multiply. I'll just label A, B, C again. We're going to multiply to get 48. And we're going to add to get, don't forget the negative, negative 14. So again, start with trying to figure out how do you multiply 2 numbers to get 48 and see if you can add them to get 14. You should try to see if you can do it and find that combination, because it can be difficult sometimes. So think about some options. You have 24 times 2. Not going to work, right? You have 4 times 12. Not going to work. All right, I'm trying to think about putting them together to get 14, and there's no way for that to happen. How about 6 times 8? If you multiply that together, you'll get 48. If you add them, you get 14. We need to get a negative 14. So how are we going to change that? How else can we get a positive 48 when we multiply? They both have to be negative, right? So if we come down here and do negative 6 plus a negative 8, that gives you negative 14. So these are our magic numbers. And we set up our 2 parentheses, x and x, and our numbers are negative 6, negative 8. You just have to practice getting that right combination so that you can write it out correctly. And that's probably the hardest part, trying to play that little game of figuring out. You have to know your multiplication tables and know those skills to be able to apply it here. All right, how about part C? Again, label A, B, C. As long as the A value is 1, we're good. We have a C value of negative 10. I'll put that on the side here. Negative 10. And B is 3. So we're multiplying to get negative 10. Not many options, and that's always easier when there's not many options. You have 10 and 1, 2 and 5. It looks like it's going to be 2 and 5, but one of them has to be negative. Since we're trying to get a positive 3, which one should be negative here if we add them together? Oh, dear Lord. There we go. We want to get a positive 3. We want the 5 to be positive and the 2 to be negative. And that should work. Negative 10, add these together, you get 3. So our combination would be x, x, and then a minus 2, positive 5. Again, you can always check these to see if they're right. We're going to do one more and then move on to the more difficult kind. So again, we have our C value is negative 40. We're trying to multiply for that. B value is negative 6. Find the combination. What do we have for 40? We have 2 and 20. We're trying to get negative 6. So 2 and 20, they're really spaced out. We want something that's closer. What else would work? 5? 5 and 8? That's a little too close, right? 5 and 8 would give you the 40. But putting together 5 and 8, you're not going to get a difference of 6. So what else would work? What about 10 and 4? and we make the 10 negative. Let's see if that works down here. Does that give you -6? It sure does. This would also give you -40, so this would work. Now we have m's here, so just be careful. m, -10, +4. There it is. It's factored. Okay, so there's some huddle problems to do after that. There's 6 of them you can try. And then we're going to move on to the one last piece that includes the old stuff we did, GCF. So do those 6, and then we'll do a couple more. So the last set that we're going to do, sometimes there is a GCF that's in the trinomial. Remember GCF, factoring that out. So we can first do that, factor it out first. Now we have to make sure we look for this in every problem. So if we look at these next couple of problems that we have here, factor each polynomial completely, it says. So we have to first look and see if there's a GCF. Now remember, we're trying to make sure that the a value here is a 1, and right now it's a 2. So we can't do our shortcut method if this a value is not a 1. So that means we have to see if there's a GCF between all 3 of these terms, and there is. A 2 goes into all of those. So I'm going to pull out a 2 first. If you remember how we did this, we put a 2 here, and we divide everything by 2. So divide that by 2, you get x squared, or 1x squared, plus 5x, and then divide that by 2, minus 24. So that's what we used to do in our second day of doing factoring, or I guess it was our first day of factoring, but this was on day 2. We learned how to do a GCF. But now we have a problem where a is 1, we have a b value and a c value. So we're going to be looking at a c of -24, trying to multiply to get that, and a b value of 5. So how do you get to multiply to get 24 and add to get 5? So they're probably both going to have to be probably different signs, right? With a positive and negative. What would that be? Again, you should definitely try to figure out yourself. 3 times, I think 3 and 8 will work, as long as we have the -3. So on this one down here, -3 plus 8. And on top, -3 times 8. So that should work. So how do we finish this? We keep the 2 on the outside. Now we just break this one big set of parentheses into 2 sets like we did before. And then we put in our values. X, we have -3 and a +8. And so your entire answer, including the 2 on the outside that comes down, is this. So I'm going to do 3 more, and then we're done. All right, so this one here, if you notice here, we have x cubed, and we've never talked about that one before, not with this shortcut method. So we should be taking out more than just a number here. We can take out a 3, because 3 goes into all of these. We want this out front number to be 1. We'll take out a 3, and we can also take out 1x. And then we write in parentheses what's left. So divide by 3 and take out an x. So this would be x squared, which we have to have this in order to factor. All these other ones are also x squared. Minus, divide that by 3, you get 3. Take out an x, there's only 1 left. Minus, divide that by 3, and that would be 18. No x left. Took out an x, there's nothing there. So now we're looking at, our A, B, C. C is -18. B is -3. There we go. How do we multiply to get -18? That would be, well, we have 9 and 2. That probably won't work. We have 6 and 3. That might work. So 6 times 3 and 6 plus 3. But one of these has to be negative. We're going to make the 6 negative to get a -3. So make a 6 negative here. So we bring down the 3x, make our 2 separate parentheses, and then we put x and x here, do -6 and a +3. And that's it. We have 2 more. This one looks a little worse because we have the y in here, but that's okay. If you notice, there's a y in each one of these, so we're going to take a y out anyway. And what do we have up here? We have 5, 35, 150, so 5 can come out. How about x's? X to the 4th, x cubed, x squared. The lowest one we have is x squared. All right, and then we're going to write what's left in parentheses. So divide each one of these by 5. Take out an x squared and a y. So we'll be left with x squared, which is what we need to have. And then finish off the rest. See if you can finish the rest. Divide this by negative or by 5. See what you get. It would be 7x. Took 2 out, so there's 1 left. All these y's are going to go away. And then divide that one, 150, by 5. That would be 30. X squared goes away, and so does y, so nothing left. So now we're looking at b and c here. Negative 30 is c. B is negative 7. So we're multiplying to get negative 30. Seems like maybe 10 and 3 would work. And we'll make the 10 negative. So over here we have negative 10 plus 3. That should give you negative 7. So that works. So keep the outside like we did before. 5x squared y. And then we write this in 2 sets of parentheses. X and x, our 2 numbers were negative 10 and a plus 3. And that's your answer. Fully factored. All right, one more. What can we take out of these 3? A 2, I think. Take out a 2. Nothing. We cannot take out a 4 because 4 doesn't go into either of those 2 numbers, right? So we can only take out a 2 from all those. So we get 2x squared. Can't even take out an x because there's nothing on the end here. Plus 11x plus, divide by 2 there, 5. So now we have a b and a c, a 5 and 11. Well, no, we don't. We actually have to stop here because we don't know how to do this with a number out front that is not anything but a 1. So because a is 2, we don't know how to finish this. Not yet, at least. So as far as we're concerned, all you can do with this problem right now is do a GCF, and we'll circle it. So again, it's very important that you realize that you cannot continue doing this stuff over here unless the outside number on the x squared is 1. That's why it says in the very beginning of this lesson, trinomials with a equals 1. If you don't have that, you can't do it. So every other problem that we just did before that, right, was able to become a 1 by factoring out that front number. We factored out a 2 there, we factored out a 3 here, and then we factored out a 5 here to make it 1x squared. Here, you cannot do it, not that you know of. We will learn how to factor these later, but not right now. So that's all you're going to do is look for a GCF, take it out. As long as you have this to be a 1, then you can continue doing what we've been doing with the BC stuff and finish it with this. This one, you can't do it, not any further. So you have another set of team huddles. Just make sure you keep that in mind. If you try to factor out GCF and it doesn't come out to be 1x squared, you're done then. You can just circle it and be done. So that'll be all for day 3 for mid-chapter 6. You can finish both huddles and don't forget to do the warm-up, which is only doing GCF.